The skeleton consists of 206 bones in an adult human being. It provides the framework to support the body and give it shape. Human beings have what we call an endoskeleton, endo meaning inside, whereas insects have an exoskeleton, exo meaning on the outside. Basically, the skeleton gives us maximum support and protects our internal organs, our squishy organs like the heart and the lungs and things. It also aids with movement for the body. The skeleton is also the site of blood cell formation. So our white blood cells and our red blood cells and platelets are made within the red bone marrow within the bones. And the skeleton is responsible for storage of important minerals like calcium and phosphorus. The skeleton can be divided into two main parts, the axial skeleton and the appendicular skeleton. So the axial skeleton is everything you see here shown in blue. It's made up of the bones in the skull, the backbone, and the rib cage. These bones all lie on or around a sort of imaginary line down the middle of the body. The appendicular skeleton is everything shown in red. It's made up of bones of the shoulders, the upper limbs, the lower limbs, and the pelvis. So the functions of the skeleton are basically to support the body, to provide that framework for muscles and soft organs to attach to. It protects all of our vital organs, like the rib cage protects the heart and the lungs and everything. The pelvis protects the sexual organs. It provides movement with the aid of skeletal muscles attached to the bones. Storage of minerals, like I said, calcium and phosphorus, and then blood cell formation. Our white blood cells, red blood cells, and platelets are all made in the red bone marrow within the bones. We also have yellow bone marrow, which is more of a fat storage. It's the red bone marrow that makes the blood cells. Consider this, what would we be like with no skeleton whatsoever? Well, without a skeleton, you wouldn't be able to stand or even move. You'd have no structural frame whatsoever. Our internal organs would be poorly protected with no skeleton, and we'd be short on calcium levels too. So there's different types of bones within the body, the main ones being long bones. So they're longer than they are wide, just like their name suggests. They're slightly curved to make them stronger, and the bones in your fingers are examples of long bones, as well as the bones in your thigh, your femur. Short bones are sort of knobbly nugget-shaped bones. They're nearly equal in length and width. You would find these bones in your wrists and your ankles. These are examples of short bones. Flat bones would be thinking of things like your shoulder blade, your scapula is the correct term for that. That's an example of a flat bone, as well as the ribs. The ribs are considered flat bones. They basically provide protection in the body and also give surfaces where muscles can attach to. And then we've got irregular bones. They've got a complicated shape and they don't fit into any of the other groups. An example would be the bones which make up your backbone. So here we've got an example of a long bone. Long bones are hard and dense and provide strength and structure as well as mobility to the body. So the femur would be a great example of a long bone. It's the longest bone in the human body. It's your thigh bone. Your femur is your thigh bone. And it's got a long shaft, which we call the diaphysis, and then it's got two ends, which we call the epiphyses on either end of the long shaft. So these bones contain compact bone and spongy bone. So the compact bone is made up of dense circular layers and it forms the outer layer of all bones, whereas the spongy bone is strong and light. It's lighter in weight as well. It's got spaces in between and it's usually found at the ends of the long bones. Ligaments are tough strands of connective tissue which hold bones in place. So they connect bones to bones and they hold the bones in place at joints to prevent dislocation. Ligaments are elastic, so they can stretch to loosen a joint and help you move around more easily. Tendons are made up of a sort of tough fibrous cord, sort of bands of cords, and they're made up of collagen fibers. They're strong and flexible and they help with bending at the joint. So tendons connect muscles to bones and ligaments connect bones to bones. A joint is a site where two or more bones come together, and we use the word articulate for when bones join together. So they're places where bones meet. Some, such as those between the bones in your skull, are what we call fixed joints. They can't move at all, but most joints are movable. The most common type of movable joints are called synovial joints because they contain a lubricating liquid called synovial fluid. We're going to look at that further on. Like I said, the bones of your skull, they are fixed joints. They've got, they're highly irregular and immovable. They're what we call them sutures, and they've got serrated edges that kind of lock together with fibrous connective tissue. So when you're obviously born, your skull bones, can sort of slide over each other to allow exit via the birth canal, and then they join, and as you develop and grow, they sort of lock together and fuse where they're no longer movable, so they become immovable joints as you age. Synovial joints are the type of joints found between bones that move against each other. So any movable joints have inner surfaces lined by smooth, slippery cartilage, and they're lubricated by this synovial fluid, which is a thick sort of fluid secreted by the synovial membrane. So the synovial membrane is just a special layer of cells that lines the joint capsule. So an example of a synovial joint is the ball and socket joint. Most people know where that is. There's a type of ball and socket joint on either side of your hip and as well as your shoulders. So it's basically a round-ended bone which fits into a fixed cup-like socket, and it lets you swivel your leg around or your arm around in many directions. So it gives maximum rotation in comparison to the other joints within the body. Another example is a gliding joint. So gliding joints sometimes are referred to as sliding joints. The surfaces of the bones are flat or nearly flat, and they enable the bones to slide over each other, just like their name suggests. So they can move from side to side or back and forth. Bones in your wrists and ankles would be examples of gliding joints. There's a pivot joint as well, what we call a pivot joint. It's found between your top two vertebrae, and it allows you to turn your head from side to side. So the atlas joint is the top bone in your cervical spine. Sometimes it gets referred to as C1 for cervical 1, cervical vertebrae 1. It's named after the Greek god Atlas, who held up the world on his shoulders. That's apparently where the name comes from. And the axis is the second cervical vertebra, so it gets referred to as C2. And the pivot joint itself is found between those two vertebrae, between the atlas and the axis, and allows the head, like I said, to turn from side to side. The spinal column encloses the spinal cord as well as the fluid surrounding it, which we call cerebrospinal fluid. Each small bone forming the backbone is called a vertebra. So there's usually 33 in total, and they're connected by ligaments and vertebral discs. There's usually 7 cervical at the top of the vertebra spine, and there's 12 thoracic, 5 lumbar, and 5 sacral. And right down at the very bottom, it's saying 4 to 5 coccygeal vertebrae. In humans, it can vary, that number can vary in total between 32 and 35, but the average person, they say, has 33, and it's because these bottom 4 to 5 coccygeal vertebrae can vary. So the functions of the vertebral column are to support the upper body, protect the spinal cord, and also allow movement of the head and the trunk. So the vertebrae themselves are just a series of small bones. They form the backbone or the vertebra, whatever you prefer to call it, and they have these projections which sort of stick out, as you can see. We call these projections sort of articulation sites. So it's where muscle can attach or other bones can come together. There's a hole in the centre which you can see, which allows entry or passage, I should say, of the spinal cord. Between each of the vertebrae are invertebral discs. So these structures act like cushions. They're made up of fibrocartilage, and they're found between every single vertebra within the spine. They basically act as shock absorbers and keep the vertebra separated when there's any sort of impact from activity, any sort of activity, running, jumping, whatever. They also protect the nerves that run down the middle of the spine. So if you have a spinal injury, depending on whereabout in the spine that injury is, it can affect the level of paralysis. So the higher up the spine, the more severe the injury. So if you've got a cervical spinal injury, it affects the majority of the body. So you could become mostly paralysed, quadriplegic, if you've got an injury in the cervical region. If you've got an injury in the thoracic area, it usually affects the upper chest, the mid-back and the abdominal muscles. Sometimes you can still have some arm and hand functions, but not always. If you've got an injury in the lumbar region, it can affect the hips and the legs. So a person might still need the use of a wheelchair, or they might walk with braces or something if they're got any sort of injury there. And then if there's a sacral spinal cord injury, it usually affects the hips, the back of the thighs, the buttocks and the pelvic organs. So if individuals who have a sacral spinal cord injury, they're most likely able to walk at that level. So the lower down the injury is, the better the prognosis for mobility. Well, that sums up the skeletal system. I hope you enjoyed that video. Please look out for my next video on the muscles, which discusses the skeletal muscles attached to the skeleton which aid with movement. Please like and subscribe to my channel to receive a notification for my next video.